Okay, welcome back to the revision series. Maths again today and fractions again today. Such a massive area of maths, fractions, and an area that people find difficult. Every time I do a revision video on fractions, I realise I could really explain that a bit better, or I really need to talk about this. I've realised that converting fractions is an important thing to talk about, especially converting improper fractions to mixed numbers or mixed numbers to improper fractions. I'll explain what all those things are if you don't know. And as you can see on the screen, there are lots of different applications for this method. We need it because a calculation might not be possible without converting. We aren't asked questions where we're taking eighths away from eighths all the time, or we've got a mixed number, we've got an improper fraction. We need to organise ourselves and convert from one type to another. It helps in arithmetic and it helps in word problems as well. So I'll show you the methods, I'll show you the reasoning behind it all, and then I will show you some SATs, some year 6 SATs, arithmetic and reasoning problems of recent years to show how we can apply it. So off we go then. Here is already in this first question, an arithmetic question. 1 and 1/15, take away 2/5. Got a couple of different things we need to do here. The reason I've added a fraction wall over the side here is so we can see equivalent fractions. Got a 1 at the top, and then we can see that a half and another half is the same as 1. Same size block, the width is exactly the same, and it's the same as 1. We kind of know that intuitively. So 2 halves equal 1. That method continues the whole way down. If we look at eighths, for example, 1, 2, 3, 4, 5, 6, 7, 8. 8 eighths equal 1. It may seem like common sense, but it's going to be a very important part of converting the fractions is to remember what we're breaking them into. So over here, we have 1 and 1/15 take away 2/5. So first things first, we need to make the denominators the same. We need them both in 15ths. So don't do too much at once. Stay with 1 and 1/15. I'm going to convert this other fraction into 15ths. I'm going to circle this to remind myself to do both the numerator and the denominator. So we've got 15ths down here. 5 times something is 15. 5 times 3. So 2 times 3 is 6. So that's the first step. We've got both of them in 15ths, which helps. But now you can see we still haven't solved this problem because I need to take 6 15ths away, but I've only got 1/15 here. So what I need to do in order to solve this is I need to give myself more 15ths. So I need to cash this in. It's like having a £10 note and breaking it into 10 £1 coins. If I owed somebody £3, for example, I couldn't give them a £10 note. But if I broke it into £1 coins, I could. So what I'm going to do is I'm going to split this 1 into 15 15ths, just like we did over here. 2 halves are 1, 8 eighths are 1, 15 15ths are 1. I've got another one on here, so I'm going to add that on. So now I've got 16, just right over the top of it. 16 15ths. 1 and 1/15 is the same as 16 15ths. Now we take away the 6 that it just created. 16 take away 6 is 10. 10 15ths would get you a mark, or you could even go with 2/3 if you were going to simplify that. Dividing both the numerator and the denominator by 5 would give you 2/3, and that's the most simple form. You would get the mark for writing 10 15ths. But as you can see, you've got to make the denominators the same, otherwise you've got different sized blocks and it's not going to work. And then we are cashing in that number of holes there, 1, into the number of 15ths. Okay, so relatively basic arithmetic, but you need to work 2 steps even just to get 1 mark there. Here is a reasoning question. So from a word problems paper, Key Stage 2, Year 6 level, it says, circle the improper fraction that is equivalent to 6 and 7 eighths. An improper fraction is any fraction where the numerator, the number on the top, is bigger than the number on the bottom. So all of these are improper because we've got 67 eighths, 48 eighths, blah, 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 all the way along. What I would strongly suggest you do is, when you get a question like this, don't look at the available answers. You don't want to be led by anything without actually doing the calculations for yourself. You want to start going, oh, it looks like it would be around 62. Just to completely ignore them. You've got everything you need up here. Circle the improper fraction that's equivalent to 6 and 7 eighths. So let's split this up. 6 over here, 7 eighths over here. Okay, so if we split one of those into eights, a single one whole into eights, we've got 8 eighths. We've got another 8 eighths for 2, 8 eighths for 3, 8 eighths for 4, 8 eighths for 5, 8 eighths for 6. Why can't I draw an 8? There we go. So we've got actually 8, 16, 24, 32, and onwards. We've got 48 eighths over here. You could just make 8 eighths and do 6 times 8. And we've got our 7 eighths already up here as well. So we're going to add 5 more on. We're going to add 48. Add 7 equals 55. We're still working in eighths. Every answer is an eighth. And now I'm going to see, and I'm hoping that this answer is one of the available ones at the top. And there it is. I can be more confident in that answer if I've worked it out myself without being guided by the possible answers. And then I see, okay, 55 eighths. Well, I came up with that. It was on the list. I'm pretty confident that's going to be correct. Hopefully this fraction will help you to understand what we can break whole answers into. Here's an arithmetic example 2. You can look straight away and go, okay, well, step 1 is done for us already, isn't it? We've got both of these fractions are in sevenths, so we don't need to convert either of those two. We need to make the denominators the same. They are the same. But we've got 3 sevenths here, and we've got to take away 4 sevenths. We don't have enough to do that straight away without any modifications. So we're going to break that whole one into the number of sevenths. 1 is 7 sevenths. We're going to add the 3 sevenths that were there, and that gives us 10 sevenths on this left-hand side. Take away 4 sevenths, and we have 6 sevenths. Nice and straightforward. The question is just testing you that you can split this mixed number into an improper fraction. It's called a mixed number because it's a mix of an integer, a whole number, and a fraction together. That's a mixed number. You split it into an improper fraction, 10 sevenths, take away 4 sevenths, and we're on to 6 sevenths. Hopefully start to click with this method a little bit. And now actually I cut this from a reasoning paper, and 2 questions next to each other were both involving converting fractions. So you can see how important it is. Just in one paper, one sample paper, 2 questions in a row, you need the same skill. So question 7 up here. In a race, Ali completes a swim, a run, and a bicycle ride. The swim is 1/10 of the total distance. I'm not thinking about that right now, but what I'm noticing is, okay, tenths. The run is 3/10 of the total distance. Okay, tenths. What fraction of the total distance is the bicycle ride? So the first thing I know is my answer's got to be in tenths. If I'm given 2 fractions within the question that are in tenths, well, I'm going to have to present my answer in tenths. Might be able to simplify it, but we'll see how we go as we get on. So we need to look at the whole race. The whole race is 1. That's the whole thing, a whole, 1. But we're looking in tenths. So we know the whole race is the same as 10 tenths. That really is the hard work in this question. 1 race is equal to 10 tenths. So the swim is 1/10. The run is 3/10. We don't want to know either of these two, but we want to know what's left over. So we've got 10 tenths. Take away the swim equals 9 tenths. Then we've got 9 tenths. I'm doing every step here. You can do them both together if you want to. Take away the run, 3/10, equals 6/10. That's our answer. You can simplify if you want to. 6/10 is fine. Or you can have 3/5 underneath. Again, to simplify a fraction, I'm looking, okay, can I divide both of these by the numerator? Well, I can divide 6 by 6, but I can't divide 10 by 6. The other way to simplify is, can I halve both numbers? Yeah, I can. I can halve 6 to make 3. I can halve 10 to make 5 as well. So in its most simple form, it's 3/5, but 6/10 would get you a mark for that. So I'm going to give myself a mark. Well done me. And then question 8 is just like we did with the other question. Circle the improper fraction that's equivalent to 2 3/8. I'm ignoring all the possible answers. I don't need to look at them to get my own answer. And I've got a 2 holes. 3/8 can stay over here for a while. And I'm breaking each whole number into eighths. So each one is worth 8 eighths. Write them all out if you need to. 8 eighths, 16 eighths, add the 3/8 makes 19 eighths. So I'm working it out for myself. Now I'm going to check back and look at the answers, and hopefully I'm going to see 19 eighths there. And I do, they're all in eighths, and 19 eighths is there. I'm going to circle that and give myself a mark. Well done, me. So hopefully, throughout these questions, you realise the key point is to break the whole number into the fraction there, whether that's in tenths, whether that's into eighths. I'm sure we did it into something else as well. Whether it's into 15ths, break that whole one up. Imagine the £10 note broken into £10. And you're just splitting it up. It doesn't change what it is, it just represents it in a different way. And you can see that applications are everywhere. There's an arithmetic question there. You're going to get at least one question that you're going to need to convert a fraction within on both your arithmetic and your reasoning papers at Key Stage 2 level. There's another arithmetic, and we had 2 in a row there, so 2 quick marks, all from the same thing, breaking a whole into tenths and breaking a whole into eighths. That's the key part. So convert your fraction before your calculation is the top tip. Do all of the legwork, set it all up properly, and then the maths itself shouldn't be too difficult. When we look back into the race question, actually, once we realise that 1 is the same as 10 tenths, we've just got to do 10 take away 1 and then 9 take away 3, which we're all capable of. This is the real test, it's the conversion. And then cash in, I put cash in a whole and change it into pieces. If you're working in eighths, it's 8 eighths, 6 6, whatever you need to. And we know that's the case by looking at this fraction where we can see that 6 6 is the same as that 1 up there. Do that, stick with that method, you should have no problem. It's another skill that you use on its own in an arithmetic paper or as a stepping stone to solve a reasoning question. I'm sure there's loads more topics around fractions that I need to still do videos on. Let me know what you'd like to see and I'll continue making the videos. Hopefully that's been helpful. We now know how to convert a mixed number into an improper fraction and later on I'll do another video from improper to mixed. See you all soon. Ciao.